So in derivative you had already studied various rules of derivatives, like what will be the derivative of a constant, what will happen if a constant is multiplied to a function of variable x, if you are considering x as an independent variable and then you are finding the derivative. Then what will happen if you add or subtract the functions, to have addition and subtraction of two functions, and then you have to differentiate. So you had studied the linearity property of derivatives, then product rule, quotient rule, chain rule, as you have told. And in addition to that, you studied the basic rules of derivative. So now when we are going to study integration, as we say that integration is a reverse process of derivatives. So that's the reason it is also called as antiderivative. Okay, so let's begin. What is happening? Give me a moment. Let's begin. So when we talk about integration, we say that it is a reverse process of derivative. It is also called as antiderivative. So if we consider y is a function of x, then we denote the derivative of y or derivative of this f of x by this notation. Okay, so let us say that this is equal to capital F of x. Then what it says, say dy by dx, which is same as the derivative with respect to x of f of x, is equal to capital F of x. Now if we want to get this function, return back to this function given the derivative of a function, then we apply the reverse operator, which we call as integration. So what we will be doing, we will use integration f of x dx. So this dx, to understand it, like we integrate both sides of this term with respect to x. So this left side becomes only f of x. So this is called the antiderivative or integration. Okay, so in the notation wise, we use d by dx to represent derivative. Similarly, we use integral, here the name of function dx, to represent integration. Okay, we keep the name of the function here, so it could be y or f or any other term. Okay, so this is how we denote the integration. As one of you already said that we use derivative because it gives you the rate of change of a function. Similarly, integration is used because it will give you the area under the curve. Because later in the section you are going to study the integrals of the type a to b fx dx, which is called the definite integral, which gives you the area under the curve. But currently we will begin with the indefinite integral without limits. This is indefinite integral. Okay, so when we talk about definite integral, it will give you, say, suppose you have a function, the curve of the function, this is your x, this is y, and this is the curve of the function y is equal to f of x. And suppose you have the area as limits for x as, say, x is equal to a, this is x is equal to b, then the area covered by this curve with this limits, within this limits of x, this is given by the integration of definite integral of the function from a to b. Okay, so this is what is the application of this definite integral. Okay, so now let's begin with the main rules. Like in the derivatives, you have studied the power rule, that is what is the derivative of x power n, what will be the derivative of sine x, derivative of cosine x, and so on. In the same way, let's study some rules of integration. Okay, so let's begin now. So first rule, which is similar to the power rule, so we say that integration of x power n dx. In power rule you have studied the derivative, so this rule is x power n plus 1 divided by n plus 1 plus the constant of integration. C being the constant of integration. Okay, using C is a general notation that we represent constant of integration. Okay, this rule is valid for all values of n except n is equal to -1. If n is equal to -1, this rule is not true. Okay, so we say that this rule is applicable for all integer values of n, or so for all values of n other than -1. The generalized form of this rule is ax plus b to the power n dx. Like instead of x you have ax plus b and its power n. So it will be ax plus b to the power n plus 1 over n plus 1 plus c, again with the condition that n should not be equal to -1. Later in this unit you will see that how to derive this result by using method of integration, which is called integration by substitution. Okay, so you will see that thing, but this is the generalized rule. So let's see how this rule works. So what thing to be noticed, whatever is the value of n, increase the means whatever is the power of x, increase the power by 1 and divide by the same power. So for example, suppose you have, say, integration of x power 4 dx. So in this case your n is 4, right? So x to the power 4 plus 1 over 4 plus 1 plus c, which is nothing but x to the power 5 over 5 plus c. Suppose we take another example. Say you have integration of, instead of numerator, if it is x to the power 1 over x power 4 dx, then do we have any rule so that we can bring the power up? See, it is important that the term should be in the numerator. It should not be in the denominator. If it is in denominator, do something to bring it up. Okay, so what we can do, we can rewrite it as x to the power -4 dx. I hope you know the rule of indices. Like we have, if it is x power a over x power b, we can write it as a minus b. If it is x power a times x power b, it is a plus b, and in place of x power a we have 1. So it is just writing it in terms of reciprocals, which will become x power minus b. So these are the rules of indices that you already know. You have to use it to convert the term into the form for which rule is available. So now here in this case your n is -4. So see the difference, here n was 4, here it is -4. So let's apply the rule in the same way. This gives you x to the power -4 plus 1 over -4 plus 1 plus c, which is nothing but x to the power -3 over -3 plus c. The reason we are saying that this rule is not true for n is equal to minus 1, because see what will happen when n is equal to minus 1. When n becomes equal to minus 1, it means n plus 1 equal to 0, which shows that the denominator becomes infinite. If denominator becomes 0, so any number divided by 0 is infinity. It is not defined. So since it is giving you indefinite term at the value of n equal to minus 1, that's why we say that this relation holds for all the values of n other than minus 1. We will see later that what will happen when n is equal to minus 1. Okay, so let's take another example where you have to work again with the rule of indices. Say suppose you have x power 2, x power 3 over 2 divide x power 7 dx. Okay, so in this case, as it is in the form of, say, it is in the same form of the rule x to the power n, x to the power n, but what is the thing here? X to the power n, but here you don't have one x. You're not having one x, you are having 3 x's. So what you have to do is you need to combine all these terms together to make it in the form x power just one number dx. So to do that, you have to make use of this rule of indices. Okay, that is, if it is in divide, we will subtract it. If it is in addition, we will, in multiplication, we will add the powers, provided base is same. So let's see what we can do with the numerator. We can write it as x power 2. This is in multiplication and base is same. So 2 plus 3 over 2. So I will write this here, 2 plus 3 over 2. And 7 is in division. So 7, when b is in division, when it moves up, it becomes negative. So we write it as minus 7. Then simplify it. So what will get integration of x to the power, this 3 by 2 minus 5. 3 over 2 minus 5, which is 2 minus 7 dx. So if you simplify 3 over 2 minus 5, this gives you 2, 3 minus 10, which is minus 7 over 2. Okay, again which is a value other than minus 1. So you get it as integration of x to the power minus 7 over 2 dx. Now still the integration is not over. So far what we have done in these steps, we converted the function into the form so that rule will be applicable to this. So now here in this case n is minus 7 by 2. So what this will give you? X to the power minus 7 over 2 plus 1 minus 7 over 2 plus 1 plus c. And when you simplify it, it will give you x to the power minus 5 over 2 minus 5 over 2 plus c. You can further rewrite this term as just taking this 2 into the numerator, minus 2 over 5 x to the power minus 5 over 2 plus c. So now we have seen that this rule is not applicable when n is equal to minus 1. Let's see what will happen when it is minus 1. So when n is equal to minus 1, so we get the term x to the power minus 1 dx. So we can rewrite it as 1 over x dx. So for this one, we have another rule, which is ln of x plus c. This is natural log of x. Okay, the generalized form of this rule is ax plus b to the power minus 1 dx, or integration of 1 over ax plus b dx. This is ln of ax plus b plus c, where a and b are constants, similar to the values of a and b, which is constant here. Okay, again you can prove this rule by using substitution. It can be proved by using integration by substitution. Okay, that you will be studying later on. Okay, so if it is direct, then you don't have anything here. sorry for this, let me just clear it. Is ln over a. This modification, I missed out this a. A is nothing but the coefficient of x. Okay, so if I'll give you example related to this rule, like suppose how you are going to work on it. Say if you need to integrate 1 over 3x plus 7 dx. So what it will be, as it is matching to this rule, you have a is equal to 3, b is equal to 7. So what it will give you, the rule gives you ln of 3x plus 7 over a is 3 plus c, the coefficient of x. Okay, on the other hand, if you have say integration of 1 over x minus 8 dx, so it will be ln of x minus 8 over, now the coefficient of x is 1, so plus c. So this constant b is not playing any role here in the denominator, it's only just the coefficient of x. It was 3, so it came here. Now it is 1, so 1 came here. Okay, so let's move to another rule. See, we have used this rule. Now we know that derivative of sine x, if you remember this rule for derivative, you can easily get the rules for the integration from it. See, if you have say here derivative of sine x is cosine x, so as I showed you earlier how we are getting the integration. So if we integrate both sides, what we will get, integration of cosine x dx will be sine x. Similarly from here, if derivative of cosine x is minus sine x, if you take integration, you will get integration of minus of sine x dx is equal to cos of x, or you can say that integration of sine x dx is equal to minus cosine of x. Of course, there will be constant of integration. Okay, so in this case it will become c, so we'll make it as c1. Okay, so that's what I'm saying. If you remember the rules of derivative, it is easier to get the rules for integration. So let's work on it. Let's see the third rule, integration of say cosine of x dx. It is sine x plus c. Now if you are writing it in a generalized form, cosine of ax plus b dx. So it will be sine of ax plus b over a plus c. You can relate it with the derivative where you have used chain rule. You remember when you differentiate sine ax plus b, what will happen? Derivative of sine become cosine ax plus b here times the derivative of ax plus b. So ax plus b and its derivative, which is a. So in the derivative it is coming as multiplication, but in integration it will comes as a division. So it will comes into the denominator. Okay, so what I am saying is, if you will differentiate sine ax plus b, so what it will give you by using chain rule? Cosine of ax plus b times a because of this derivative. Derivative of ax plus b with respect to x. So this will give you, this will comes in when you take the integration for cosine ax plus b, this a comes into the denominator and it will be here. So again you can see the application of this as say integral of cosine of 7x plus 2 dx. So it will be sine 7x plus 2 over 7 plus c. Just the direct integration, direct substitution of the formula. If it is what it was a, it becomes a. Okay, another example, say integration of cosine of x minus 7. So remember that this angle remains same, this argument, angle of the function. So sine of x minus 7 over 1 plus c. It's not mandatory to write 1 every time. Okay. So similarly, if we move to other rule, we'll get different rules. Say, as I showed you there, integration of sine x, or say sine ax plus b dx is equal to minus of cosine of ax plus b over a plus c. Sorry for this. Over a plus c. Similarly, we know that means we will get these rules from here. We know that integration of secant x tan x, this all rules. Because the derivative of exponential function is exponential function, we get the integration of exponential function as exponential function. We get these rules from here, the rules of derivative. Okay, so see, these are the rules. So you can see this rule, derivative of secant x is secant x tan x. So corresponding to this, we get the rule, integration of secant x tan x is secant x. Okay, and the same way, if we say the derivative of cosecant x is minus cosecant x cot of x, then integration of cosecant x cot x will be cosecant x. Sorry, I missed writing this rule. Okay, so this is how it works. Similarly, you know that where it is, these rules, fine. So when you write down this rule, what will happen here? Since we know that derivative of cosecant x is minus cosecant x cos x, so we can write integration of cosecant x cot of x dx will be minus of cosecant x plus c. Similarly, if you look at this rule number 20, for this 20, what will happen here? Rule number 6. We get the rule as integration of cosecant square x dx is equal to cot of x. Okay. Also, we know that integration of derivative of e power x is e power x. So integration of e power x is also remains e power x. Of course, the constant of integration will be there. This rule can be written in standard format as ax plus b dx, which will be e power ax plus b over a plus c. Again, following the same concept here, as it was a divided by the coefficient of x. So similarly, in the exponential rule, it is divided by the coefficient of x. So you can easily get these rules by the rule of the derivative. Now, to make it easier, means if you don't able to follow like this, you can do it like prepare a table, okay, where in the left column, first column you will write the function fx, in the second column you write the function, the derivative of the function f of x. So suppose if it is sine x, derivative is cosine x. If it is cos x, derivative is minus sine x. It is exponential function, it is same. If it is logarithmic function, it is 1 over x, and so on. Okay, so what you can see is when you are doing integration, you are moving from left to derivative, you are moving from left to right. For integration it becomes you have to move from right to left. For integration it means you look for the function here in the second column and the corresponding integration term is in the first column. Like integration of minus sin x is cos x, integration of e power x is e power x, integration of 1 over x is ln of x, and so on. Okay, so this will be easier for you when you want to memorize the rules. Okay, so let's begin. Let's see how the linearity property works in integration. So we have seen all these functions, the integration of all these functions separately, individually. Now we need to know that what will happen if we need to find integration of sum or product of two functions. Say integration of sum of two functions. Then it is same as finding the integration of first function separately, integration of second function separately, and adding the result. Okay. Similarly, if in place of addition we have subtraction, rules remain same. Just instead of adding the terms, we will subtract the two terms. Okay. Also, if we have a scalar multiplied by a function of x and we need to integrate it, k being scalar or you can say as a constant. Okay, then what will happen? The scalar will come outside the sign of integration, k times integral of fx dx. Okay, it will come outside the integration sign. So let's see how it works with the help of example. Suppose you have a combination of function, say integration of 3x minus 7 cosine of x plus 10 e power 2x. You need to integrate this term. So in this case, what you have to do, first of all, you have to check whether the functions are there or not. You have the function x, here you have the function cosine x, here you have the function e to the power 2x, and we have the rule of integration for each one of them. Okay, let's quickly see what are the rules for this one. The matching rule is x power n dx, which says x power n plus 1 over n plus 1. For this, the matching rule is cos of ax plus b, or you can simply say cosine of x, cosine of x dx, which says it is sin x. And for this one, it is matching to the term rule ax plus b dx, which says it is e power ax plus b over a. And of course, there are integration constant with each of the term. But when we are integrating, we are not going to write c plus c plus c one after another. Instead, what we will do, we integrate all the functions and then at the end, we will write one constant of integration. Because even if we say for the first one, if I say c1, here say c2, here c3, then we can add them all and make it as another constant c. Okay, so it is in this way. So let's work with it. First term, integration of 3x. 3 being constant can be taken outside the integration sign using this rule. 3 times integral of x dx. X means x to the power 1. So here n is 1. So it becomes x power 2 over 2. Okay. So it is 3x square over 2. For the second term, 7 cosine x. Of course dx is there. So 7, take it outside, cosine x dx, which gives you 7 sine x. Let's say we add the constant of integration c1, here c2, And for the third term, it is 10 e power 2x dx. Then by using the rule, it is 10 e power 2x over 2, which plus c3, which can be simplified to 5 e power 2x plus c3. Now substituting these values in the main term, in this one we get integral of 3x minus 7 cosine x plus 10 e power 2x dx is equal to, for the first term we have this 3x square over 2 plus, for the second term this one, of course we can write c1, 7 times of sine of x plus c2, for third 5 e power 2x plus c3. And as I said you earlier, we can always add all these constants together because we are not having a specific value, and name it as another constant. 3x square plus over 2, 7 sine of x plus 5 e power 2x plus c, c being the constant of integration. So in general we don't follow this practice of writing the integration term with each term, constant of integration with each term. We don't do that. Instead we will add it finally after integrating all of the terms. So you can say that integration of 3x minus 7 cosine of x 10 e power 2x dx is equal to this term. This is how you use the linearity property of the integration, okay, for different terms. Okay, I just want to ask one thing. We forget the very basic rule. We know that derivative of constant is 0, k being constant, okay, but what will be the integration of constant, k being constant? It will be constant times x plus c. Okay, how does this rule comes? To understand this, it is k dx. Can I write it as integration of k? Constant means x to the power 0 dx. Can I add this term? Because any number power 0 is 1. So now using the rule, what we get, k integration of x to the power 0, this. So what we will do here, we increase the power by 1 and add by the power plus c. So this gives you k x plus c. So we get our rule, integration of constant with dx is equal to kx plus c. So how this rule is applied? It's simple. Like you have, say, integration of 7 dx. It will be 7x plus c. If I say integration of sine of 3 dx, what it will be? So for this one, you are getting confused that it is sine of 3. So it means this rule to be used, right? But now check one thing. In sine rule, we have x. But here, if we look at here,
Yes.
in this rule, it is just sine. There is no x. No x means it is a constant value. I mean, you can able to calculate this value by using calculator. It will give you a number, a numerical value. So instead of this rule, you have to use this rule here because it is a constant multiplied by dx, isn't it? So this will become sine of 3, which is a constant, times x plus c. Let me don't put dot here. Okay, sine x dot 3. Sine of 3 multiply x plus c, because see here no x. It is different than the term integration of sine 3x dx. Here you have this term x. So it is not a constant. It is not constant. Non-constant function. So yes, you have to make use of this rule. So here it will give you minus cosine of 3x over 3 plus c. Okay. So note the difference. Here you have to make use of this rule. So this is for your understanding. Similarly, like suppose if I have example as integration of ln of 7 dx. Again, this value is not having any x. It is a constant value. So again, apply the rule of constant plus c. I have a question. Can I write it like sine of 3x? This term? Is it possible? And this term as ln of 7x? Think about it. Can we? Be careful. It is sine of 3. This is constant value. This whole multiplied by x. So you cannot write it like sine of 3x. Yes, but you can write it as x sine of 3 plus c, because multiplication is commutative. So you can write it like this. Similarly here you cannot take x inside the argument, but you can write it as x ln of 7 plus c. Okay, so note this thing carefully. Don't do such kind of mistakes. Okay, so now we have this rule generalized. We have this rule for x power n dx. Now suppose we interested to know that how do we get this rule. Sorry, here it should be multiplied with a as well. Okay, so suppose for instance we have an example of say 2x plus 5 to the power 3 dx. Okay, now from all the rules of integration that we have, just forget about this kind of rules with those with ax plus b. Just think about this. Third rule number 3, 5, 7, the rules at the odd numbers. So this question is matching to the rule number 3, right? X power n dx. So what we will do here, I have mentioned this rule here. So this is matching to this rule, right? So what we will do, we will try to convert this term into this form. So what is required here? We need a variable x. We don't want anything in addition or subtraction. Okay, but in place of x we have 2x plus 5. Then we need n. Okay, in place of n we have 3. So we have n is equal to 3. So to apply this rule, what we will do, we will use the change of variable. We change it to a new variable, say u. So what we will do, we will write u as 2x plus 5. After converting u as 2x plus 5, what we need to do, we need to change this dx as well. So because in the entire question there should be only one independent variable. So if you have all the expression in terms of x, it should be in terms of x. But if you are going to change it in terms of u, then you should change this term also in terms of du. So what we need to do in this integration process, you will use the derivatives as well. As we need the value of du, what we will do, we will differentiate this term. So when you will differentiate it, 2x plus 5, it gives you 2 plus 0. So from here, what you will get the value of du as 2 dx. Now we will make use of this u and du, and instead of du we get the value of dx, du over 2 as dx. So let's du over d, let me just erase that term. So we will get du over 2 is equal to dx. Okay, so that we can replace it here in this term. So let's consider 2x plus 5 to the power 3 dx. What it will become? In place of 2x plus 5 we have u to the power 3 we are not changing. In place of dx we have du over 2 and the integration sign. So it gives you half u power 3 du. Now you can use the same rule, but to this one, for this function, what is difference? In place of x you are having the variable u. So the answer will be changed in terms of u to the power 3 plus 1 over 3 plus 1 plus c, which gives you half u to the power 4 over 4 plus c. Okay, in short you can write it as u power 4 over 8 plus c. Now what you can see here, your answer is in terms of u, but your question was in terms of 2x plus 5. So we need to substitute back by using this equation, the value of u. So this gives you 2x plus 5 to the power 4 over 8 plus c. So this is the integral of this term. Now if we use this direct rule to check our result, see 2x plus 5 to the power 3 dx. By the direct rule we have 2x plus 5, it is 3 plus 1 over 2 times 3 plus 1 plus c, which is 2x plus 5 over 4. This is 4 times 2 is 8 plus c. So you have both the ways. So this is how the rule is derived, by using the method of substitution. So remember the steps. Step 1, select the value of u, take the derivative, find the value of dx, and then change the variable from x to u and integrate by using the rule. So this is how integration by substitution work. You can apply the same rule even to derive the rule of cosine of 3x plus 2 dx by taking reference of the rule of cosine of x dx is sine of x plus c. In this case, you should be taking this argument as u, and so on.